Hello everyone, welcome to this video. In this video, I am going to show you how to find joint displacements in pushover analysis using SAP2000 and also how to plot base shear versus interstory diff or diff ratio in MX Excel only. Okay, let us begin. Okay, this is my structure. This is a 2D frame of 6 story. So I am setting, I have set my analysis options as 2D, and I define my pushover load at push UNI and push M, and I have already performed this analysis. So now let us first check our joints where we want to find our displacements. Joints will be 2, 3, 4, 5, 10 and 25. We are providing diaphragm here, so displacements of all these joints will be almost same. So we are going to find the displacement at each floor: first floor, second floor, third, fourth, fifth, and this one is sixth floor. 10 and 25. I hope you know how to do pushover analysis or how to perform pushover analysis in SAP16. Now we are going to display this informations about, like, we are going to check, we are going to find out the displacement at each joint. So we will click display and then we will show this show plot functions. Now here we will define this plot function for our pushover cases. Now I'm consider at pushover this M model pushover. So for this I am going to find out the joint displacement. So how and joint displacement also base here. So for base here we will go for this add base functions. We will click here and add plot function. We will click this base here x direction, because this is x direction, we are providing base here at x direction. Now we are going to click OK. Now we will define our, okay, we will add our other joints plot functions. So we will click here and we'll go for add joint displacement and also click now add joint. So our joints are 2, 3, 4, 5, 10 and 12. I think 10 and 12. So first will be 2 in displacement in x direction, because we are applying pushover in this x direction. Okay, I will show you that part. Now we'll just I'm going to click OK here to this two joint ID is 2, displacement in x direction. Okay, and then we click, if we click OK here, we can see one is base here and joint 2 is come here. Let us do the same thing for the other joints. So this is joint function joint 3, okay, displacement at x directions, joint 4, displacement the x direction, joint 5, after joint 5 other joints are 10 and 25. So we'll click here, we'll write 10, we'll write 25. Okay, this is very easy. Now we'll click OK. Here we can see all the joints. So for in vertical direction we'll plot this all of this joint displacement. In horizontal direction we are interested in base shear. So here we can find for each joint base shear versus this joint displacement. Now we'll from 0 to okay, no need to write anything here. We'll click this display button and we can check all of these joints versus same displacement. This is only single for a single pushover analysis. Now we can this printable to files, like where we will get those information, joint displacements and base shear values. Here will in my desktop I made a separate folder pushover. Here is the base will let pushover data. So now I'll click OK. Okay, so done. we have just now extract those values and put it inside a text file. Now I am going to show you that my load cases that push m. Okay, so push m is direction is one direction, mode one direction, load name in one direction. So first mode one direction means this is in x direction we are applying our load, non-linear field delta we are considering. This is for push m. Okay, now I am going to, okay, now this is okay. Now I am going to show you how to plot those base shear versus joint displacement or drift ratios. Okay, this is our text file that I have made recently. Just we are going to open it. What is in this file? There is that information about base shear, information about joint displacements, first, second, third, fourth, fifth, and sixth floors. Here are those values. Now what we will do? We are going to copy and paste these things in Excel, where we can easily plot and check all those things. Just now let me copy all those things. Okay, I have just now copy all those things. Let us where our pusher. Okay, I have just copied all those things, and now what we can see here, these base shears are in negative, means in opposite direction. We have to first change it into positive. Let us check whether our Excel file is open or not. Our Excel file is this one. It's going to open. Okay, we are going to open that pushover file. Here we'll paste that thing, those things. Paste that thing. Now we'll click. This is in a single rows. Look, sorry, in single columns, not in other columns. We don't have value. First, we have to put all those things in their respected columns. So we'll select all those things. Then we'll go here, data, then text to columns. So on the basis of some, let us say fixed width can help us or not. Okay, no, fixed width can't help us. So let us go for some other things. Delimited characters. Okay, now let us say space. Can space help us? Tab and space. Okay, I think tab and space help us. Okay, we can convert this thing into columns by using tab and space. Okay, next we will going to click finish. Okay, now here are all those values. These are base shear, others are all displacements like first floor, first floor, second, third, fourth, fifth, and sixth floor displacement. Okay, now first let us convert this base shear into positive one. So how we can convert it? This thing we can convert it whatever we like, but just producting it with -1 can also help this thing. These are in kilonewton meters. Let us check the unit here. You will find the units where it's what is okay, it's kilonewton meters. So base shear is in kilonewtons and joint displacements are in meters. Okay, so this is one. So how we'll find the drift? We can find the drift by just subtracting the below floor displacement from the top one. Like here below floor displacement will be 0 for the first floor, this minus 0, and for the second floor this thing will be this 2 second floor minus first floor will give us the what drift of the second floor, and third floor, fifth floor, fourth floor are the same thing. Here we are getting some negative values. We have to just neglect all these things, just they are very less values, zero values. Now just we will drag this thing downward. We can do select these things and just click this plus in. Okay, now what we are going to do, all these values are the drift values. We can plot maximum drift versus base shear also here. You can absolutely just change this value to 0 0. So maximum drift how will find, equal to max of all these values. Okay, we'll find the maximum values. This one are the drift. So now let us plot first this maximum values versus drift. Story drift, this is not generally drift, this is okay, this is drift, and also this is interstory drift. This is interstory drift. Okay, now let us plot these things. X direction, this will be the x direction, this will be the y direction. Let us select these two things. Let us plot these two things. This one will plot. Okay, now let us change this one to base shear. Okay, and okay, in x direction we'll have base shear, in y direction we have displacement. Wrong, in y direction we have base shear, and in x direction we have displacement. Okay, let us change this thing. Okay, look, this is okay. In y direction we have base shear, and in x direction we have drift, not displacement, not drift. So this way we can plot base shear versus drift values. And next thing what we can do, we can find the drift ratio by using one more thing here, by using interstory drift ratio. Interstory drift ratio. So how we'll find interstory drift ratio? We to find interstory drift ratio, we have to know about this height. So let us check what is our height. Okay, for the first flow, I think let us check the grid. For the first flow it is 4.3, for the other flow it is 3.3. okay, so let us do the things. Interstory drift ratio for all this we have to find out. Okay, so for one what is 4.3, so we'll divide this thing by 4.3. For 2 we'll divide these things by 3.3. so all other floors are of same height, so we are getting drift. So next thing is interstory drift ratio. This is the max. This value will be the max value. So let us find our max value. Okay, and we generally use percentage for measuring this thing. So let us product it with 100. Okay, this is interstory drift ratio, and our base shear is here, so this will be our x and that will be our y. Let us plot this thing first. Okay, we are going to plot these things now. Our y-axis, okay, where is it? Okay, I have done a mistake. Let us delete this thing. Let us plot these two first. Okay, you can plot this thing, but let us okay, now change our x okay, we can change our x direction, sorry, x axis to this values. Let us check the values. Okay, this is we are getting base shear versus interstory dip ratio values. So collapse prevention, if we consider it here, then it is near 3% drift. Okay, this is the way we can plot, or we can collect data from SAP for all the joints and base shears. The same thing can be applied for nonlinear time history analysis also. We can plot time versus displacements also, can find drift. This is the way we can do those kind of things. So hope you enjoy this video, and I hope you can apply this thing in your work. So thank you and bye.